Hello everyone. Hope you are doing well. Welcome to the online platform Civil Technobricks. Guys, here we will tune for instantaneous decoding of the conceptual knowledge in the field of civil engineering, where study elaborates decoding the earth to build a better world. Today we will go through the core concepts of fundamentals of geographic information system. Shortly we can say that GIS. GIS is a computer based system used to capture, store, analyze, and display geographic data. The main objective is to support decision making using spatial information so that we can take our decision on the basis of the collected data, which is self informatory. It works by integrating maps with attribute data through the layers. Key characteristics includes are the accuracy, data integration, and visualization capability so that the GIS allows that analysis like buffering, overlay, network, etc. So, GIS is the art, science, engineering, and technology required to answer geographical questions. So, we have n number of geographical questions. So, we have to collect the answer for that geographical questions by using the GIS, which is the informatory tool, a computer based system for capturing, storing, retrieving, analyzing, and displaying the spatial type of data. So, the data capture to the GIS analysis, then decision making, and then real world action. So, this is a continuous cycle related to the real world. We have n number of questions, go for that question. With respect to that cycle, we collect the actual outcome which is required. In civil engineering, it is used for urban planning, site selection, and infrastructure management activities to collect the information or to collect the answers for the geographical questions. GIS is no longer just an software, it is the fundamental platform for managing infrastructure, environmental activities, and urban growth also. So, in today's era, the data collection is based on that GIS, which is an informatory tool on the basis of GPS and GNSS. So we have to collect the data and we have to manage the data. After that collection and management, we have to analyze that data. So we will explore that the constituents of a GIS, the core components that make our work more easy, and we get a superior activity or we get a superior choice for modern project management over the traditional paper maps. So with respect to the GIS, decision support system of a civil engineering will enhance its characteristics and its importance also. So geographic information system is a framework for gathering, managing, and analyzing data which is based on the science of geography, which integrates many types of data. Just that data is analyzed the spatial location, spatial purpose, which organizes n number of layer or a single layer or information from a layer, compare the information to another layer, or we have to visualize the layer with respect to the n number of rasters. Likewise, we can compare 2D to 3D, we can compare 3D to 3D, everything. So it is important to distinguish between the data and the information. So what is meant by data and what is meant by information? So GIS, which is a self-explanatory informatory tool. So with respect to that informatory tool, we can collect the data. That data are the raw facts such as a list of coordinates or a table of rainfall measurements like temperature variation, like rainfall intensity, everything. Information is the result of processing that data. Information is the result of processing that data to make it is useful. Just like flood risk map, for a structural health report, disaster management activity, etc. So GIS is the engine that performs the transformation. GIS is the engine which performs the transformation of data to information. So in our field of civil engineering, we use GIS to turn thousands of individual survey points into an informatory layer or information layer that can guide us for the construction of highway, for the construction of roadways, airports, each and every infrastructural project, management of that infrastructural project, or in urban point of view, municipal water network, municipal corporation activities, or irrigation activities in agricultural zone likewise. Now there are 5 components of GIS. So what are they? They are listed from hardware to software, data, people, methods. This is also a cyclic process, or we can say that interdependent process in between them. So hardware includes physical machinery, CPU, digitizer, scanner, plotter, etc. Software includes database management system, Google user interface, then analysis modules, ArcGIS, QGIS like softwares, etc. What is meant by data here? Data is of two types, spatial type and attribute type. Spatial information, attribute information, just like the example of fuel in consumption. Likewise, people, people are the users, just like managers, specialists, users, the drivers, everyone. Again, methods. These methods are dependent on the business rules and the protocols, just like the roadmap or the alignments. So the functional GIS consists of the 5 components. They are starting from hardware and software. Hardware includes everything from the high-end workstations used for processing the handheld GPS units used in the field. Software provide the tools and functions needed to store, analyze and display geographic information with industry leaders like ArcGIS, ArcPro, ISRI, QGIS, open source ArcGIS, open source QGIS, etc. Many more softwares are in market. For the civil engineering point of view, or any civil engineering firm, choosing that right hardware and software, which is most important and essential for the ensuring that large scale project files, which we can reduce that large scale project files by using that activity efficiently without any type of lag or lapse. So these components are basically data, people and methods. These components are basically data, people, methods. Perhaps that most critical component is the data, which is a huge in count. So this includes both special type of data where things are included and attribute type of data there what things are consisted. So people are the skilled professionals who manage the system, solve the real world problems. Methods refers to the specialized procedures and business rules that define how data is analyzed. With respect to that methods, people, data, in civil engineering, method might include the specific formulas we use to calculate cut and fill volumes or the environmental regulations or any other agricultural activity that dictate where we can and we cannot build our nation or build our project or infrastructural activity. So data is the most important point from that 5 components where all software and hardware, methods and people are rely on that. So which is the most expensive component. Owing towards the data, spatial and non-spatial or spatial versus non-spatial data. So spatial data, which is a geographical, that is we have to ask the question where, which shows the position. And descriptive data is the non-spatial data where we have to ask the question what includes or what is consist, so that it gives the description of that position. So geographical positioning system GPS, which is a pre-primary tool for the GIS, where which stores the coordinates latitude, longitude or XY coordinates. Likewise, just like example of bridge pier location or road alignment or any tree or any temple. Likewise, this data is linked via unique ID or nomenclature to track that record, so that we can take its input in the models or in the comparison of n number of layers. So these IDs are nothing but 001. Material is concrete, traffic is high, low, medium, material is another type of also. So we can segregate it or we can differentiate it likewise. So with respect to that description, we can store that whole data with respect to the database management system or in tables like pavement type, population density, traffic density, depth, height, width, etc. So spatial data represents where component in GIS and stores geographical locations using coordinates. Just like in civil engineering, includes pier and road alignments. Non-spatial data which represents the what component and which stores the descriptive information in the database management tables. So spatial and non-spatial data are connected through a unique ID which links map features with their related attribute details for analysis and management. Remote sensing provides spatial information while GIS integrates and manages both location based and descriptive data for engineering applications. So we are the engineers, we have to use geographical data also, descriptive data also, means we have to work on the spatial data also and non-spatial data also at a single time or at a multiple times for any type of location. The combination of both data types supports civil engineers such as infrastructural planning, transportation analysis, urban development, urban mapping and zoning, resource management, and many more. So importance of the data based on that spatial and non-spatial, or we can say that spatial and attribute. Spatial data types, or we can also say that vector primitives. The spatial data is the data where GIS is represented using vector primitives such as point, line, polygon. Point is a 0 dimension, line is a 1 dimension, polygon is a 2 dimension. They are used to model real world civil engineering features in remote sensing and GIS applications. Point, that is 0 dimension data, represents a single coordinate pair which is used for location specific features such as wells, electric poles, benchmarks, likewise. Line, which is a single dimension or 1 dimension data, consists of connected points with length and direction, commonly used to represent roads, streams, power lines, and sewer pipelines in civil engineering projects. Third, polygon, which is a two-dimensional data, represents closed areas having area and perimeter, which is used for mapping land parks, land parcels, soil patches, reservoirs, and other surface features. These vector data types, these vector data types helps in accurate mapping, planning, analysis, and infrastructural activities with respect to the use of remote sensing and GIS, or we can use the collected data for our utility management, transportation planning, water resources, and land development department. Owing towards the data collection based on the coordinate system, there are two types of coordinate system, GCS and PCS. GCS, geographic coordinate system; PCS, projected coordinate system. Coordinate systems in GIS are used to define the location of geographic features accurately so that we can map, we can survey for each and every civil engineering project with respect to the remote sensing and GIS. Geographic coordinate system is based on the Earth's sphere or ellipsoid model and uses angular units such as degrees, minutes, seconds. It is mainly used for global referencing and satellite based mapping. Projected coordinate system PCS converts the curved Earth surface into a flat 2D plane. So projected coordinate system, which is a 2D plane using Cartesian coordinates XY with units such as meters, feet, making it suitable for engineering measurements. So projected coordinate system is widely used in civil engineering projects for calculating the length, distance, area, alignment in applications such as road design, road alignment, land surveying, infrastructural planning, likewise. So projection from 3D Earth to 2D maps. Projection from 3D Earth to 2D maps causes distortion in shape, area, distance, direction, etc. So we have to select an appropriate coordinate system which is important for the GIS analysis and remote sensing applications. So our main aim is we have to select a correct coordinate system which will be more useful for getting the outcome on the basis of the selected objective in the project. Again, one of the point is the map scale concept. The map scale represents the ratio between map distance and the actual ground distance, which helps in understanding the level of detail and coverage geographical information system and remote sensing applications. Large scale maps and small scale maps. There are two types of maps. Large scale maps 1:1000, which is a scale where small scale. Likewise, we show high detail over a small area. Large scale maps are useful in civil engineering applications such as building layouts, road alignment, utility mapping, sites planning, etc. We can use large scale maps 1:1000 scale. For small scale map, which cover large geographic areas with less detail and are mainly used for regional planning, transportation networks, watershed studies, and national level GIS analysis. So, large scale maps for road alignment, utility mapping, building layouts. Small scale maps, regional planning, transportation networks, watershed studies. So, high detail, small area at a large scale map, low detail, large area in the small scale map. So, selection of proper map scale is important in remote sensing and GIS as it affects accuracy, precision, visualization, measurement, and decision making. Now, here data input methods are the most important point for data collection also, or data process also, or data store also. So we have to collect the data, we have to process the data, and we have to store the data. So analog sources, input methods, digital database, these are the three main components, or we can say that phases of data input methods. So analog sources, just like paper maps, field surveys, and satellite images, provide the basic spatial data for remote sensing and GIS applications in civil engineering. Digitization, scanning, remote sensing, keyboard entry, these are all the input methodologies. They are working in the step, collaboration, interdependent or dependent, or in cycle likewise with respect to the requirement of the analog sources. So digitization, manual tracing converts maps and engineering drawings into digital GIS vector data. Digitization converts manual tracing maps and engineering drawing into digital GIS vector data for analysis and planning. Scanning, which is the activity, automatic raster capture of maps and survey document, helps in data preservation and map forecasting or processing. Remote sensing, which where direct imagery importation or import activity is there. Satellite and aerial imagery are directly integrated into GIS for monitoring, planning, and infrastructural management. At the last, keyboard entry, typing coordinates or attributes, where we can manually enter the activity by using the keyboard. At the end, digital GIS database, which is a verified GIS storage, which have the capacity to store the data after processing in the input methods based on that analog sources. Verified spatial and attribute data entered through keyboard input are stored digitally for different civil engineering decision making. GIS data models. So if data type is of two type, vector and raster, so each and every data type have its own data model for processing or analysis. So GIS data models are of two types, vector model and raster model. So GIS data models in civil engineering mainly used for representing and analyzing spatial information. Firstly, the vector model represents discrete objects using XY coordinates such as roads, pipelines, property boundaries, land parcels, utility networks with high precision. Topology in vector data. Topology in vector data explains the relationship between the connectivity and adjacency or the neighborhood, making vector models important for transportation, drainage, and network analysis and planning. Moving towards the raster model, which represents the geographic data as a continuous grid of cells, or we can say that pixels, and its resolution dependent for accurate analysis. So raster data or raster model applications in remote sensing is best suited for digital elevation model, temperature mapping, satellite imagery, supporting terrain analysis, environmental monitoring, and planning in civil engineering activities. Civil engineering applications point of view, we can see the civil engineering use, or the civil engineers must have to be dependent on remote sensing and GIS, which supports for the planning, analysis and management activities with respect to the infrastructural domain and environmental systems. So transportation point of view, in route alignment, traffic analysis, pavement management, for efficient transportation network planning, we can use GIS. With respect to the hydrological department or water resource department, remote sensing and GIS is used for watershed management, floodplain mapping and drainage design to improve water resource planning. Moving towards the urban planning point of view or urbanization point of view, GIS supports the land use, land cover, land zoning, land mapping, site suitability analysis for facilities like hospital, parks, amusement parks, recreational spaces, landfills, etc. At the end, disaster management, which is the most important point where GIS plays a crucial role to assist in seismic hazards mapping, damage assessment, tsunami modeling for disaster preparedness among the people so that we can mitigate the risk. What are the advantages of GIS? So GIS have n number of advantages. So here listed few. GIS integrates maps, tables, satellite images, aerial images, photographs into a single platform for efficient civil engineering analysis and planning. So remote sensing and GIS improve efficiency through automated calculations of area, distance, length used in surveying and infrastructure projects. So GIS supports what if scenario modeling and predictions for transportation, urban growth, flood risk and environmental management. Digital GIS also used or it can be edited and updated easily, which is based on to manual paper map redrawing, ensuring accurate project information precisely. So GIS helps us to visualize complex spatial data clearly, which help which helps to improve the communication in between two parties or in between two persons. Planning activities, decision making process, they are all dependent on the GIS, and we can cross check the information with respect to that tool. So GIS is the building block of the data, and with respect to that data we can use the data for our sake of interest so that we can visualize, plan and execute the projects. Stay tuned guys, happy learning.